So we have two sections to cover. The first is 4.9 on circles, and the other one's 4.10 on inverse variation. Circles are really a review from geometry class. We know that a circle is a set of points at a fixed distance from a fixed point. So if we call the center of the circle point A, and we're going to call this point H, okay. And here's our radius. And a point on the circle we're going to call B, and we're going to call that point XY. So what we're going to do now is use this information to come up with the equation of a circle. We're going to do this by using the distance formula. You should have had the distance formula memorized from geometry. So distance is, so if we want to find the distance of this radius, so the radius R is the line segment AB. Distance formula is the square root of the x values subtracted and then squared plus the y values subtracted and then squared. Well, if we square both sides, we get AB squared, or R squared. And if we square this side, it just removes the square root. And just removing this AB out of the equation, we have R squared equals X minus H squared, quantity squared, plus Y minus K, quantity squared. And that's where your formula from a circle comes from. This is nothing new, you've seen it before. Remember that the center again is at HK, opposite signs. This is negative, so positive H, positive K is the center of the circle. And obviously R is the radius. So if you don't already have that formula memorized and know how to find the radius or the center, that's something that you need to review. Okay, on the next page, we'll just do a couple of examples. So again, giving you the formula. R is the radius, center is at HK. So let's just do a few different examples. One, we can graph a circle, radius of 3, and the center at 3, 1. So 1, 2, 3, 1, so there's our center. Radius of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're just counting 3 in each direction. So if we count 3 in each direction and then attempt to draw a circle, let's try again. Okay. Next one. Now I'm going to give you the equation and you have to graph it. So what we need to know from this equation is where's the center. Remember, it's opposite signs. So -4, +3 is the center. The radius is the square root of this number, right? This is radius squared. So the radius is the square root of 4, or 2. So -4, 3. 1, 2, 3, 4. 1, 2, 3. Radius of 2. My objects up here. Okay, circle with a radius of 2. Another way to ask the question is, find the equation given the center and a point on the circle. So this just really goes back to the basic idea of the distance formula, or the fact that to find the length of the radius we can use the Pythagorean theorem. So if we have negative 2, 3, that's your center, 0.14, and this is your radius. So what we can use is the idea of right triangle trig, right, and find the length of the radius that way. Okay? So you can simply count. Right? So if this is at negative 2, to go over to here is a distance of 3. Going up from here to here is a distance of 1. So this squared plus this squared equals r squared. Basic Pythagorean theorem. So 3 squared is 9, 1 squared is 1, 1 plus 9 is 10. So the radius is the square root of 10. Radius squared is 10. We'll go back to your formula, right? X minus the center of the circle. The center is at negative 2. Remember, it's opposite sign, so negative, negative, positive. So x plus 2, quantity squared, plus y, center is at 3, so minus 3 squared equals radius squared, which is 10. So basically here what you're doing is using the Pythagorean theorem. You're finding the radius, or the radius squared, and then you're using the formula for the equation of a circle and plugging in the center, opposite signs. Center was at negative 2, positive 3, positive 2, negative 3. Very simple. Remember, the distance formula is really doing the same thing, so you can use the distance formula to find the radius or use the Pythagorean theorem. Next, we're going to talk about inverse variation.